Okay, well, I'm going to get started. So welcome everybody. This Medway Green Party presentation is called Planning for the Future, and we'll be covering what our plans would be, but it is also a reference to the government white paper, which is a review of the current planning system. So this is episode 2, and it's about great expectations for a sustainable future on the Hoo Peninsula. Okay, so our planning for the future will be the first part, and we may have a quick break. And then we're hoping for a bit of a discussion session. So there's quite a lot of information on the slides. So if you want to take some notes so that you're ready to challenge and to question and, you know, make suggestions to us as well, that will be great. Okay, so your faces were blotting the screen for me. So I'm going to start here with a quote, and it's from George Clark, who's an architect, and you have likely seen him on the TV, and currently he's presenting Ugly House to Lovely House. So George said, "I have been talking about the ecological standards of buildings for 20 years. Unfortunately, when it comes to insulation and using green technologies, governments haven't got the guts to go to the necessary length to make a difference because of the influence of big house builders. Both have made it clear that they don't want to shoulder the costs that would arise." So here's a picture. Frank Lloyd Wright was the architect. I think that's correct. Bernard will say if it's different. Yep. And this house was built in 1936. And am I right, Bernard, it's a wooden house?
It's a wooden house intended to be affordable.
Okay, yes, all right. And you'll see why it's a particular interest to me later on in the presentation. We need more houses to be built, especially social housing and affordable houses to buy, but volume house builders have a product that maximises their profits while minimising their efforts. This economic model works best for them when they build on agricultural land. And you can see here agricultural land is graded into 5 different categories. And if we go onto the map now, it gives a physical, it gives a visual representation of these different areas. So if you look to the top of this map, you'll perhaps be able to identify the Hoo Peninsula, and you'll see that on the Hoo Peninsula, there's a great deal of excellent agricultural land. To the left-hand side there, I'm identifying an area of very good, and there's the green areas are good to moderate, the yellow areas poor, and the brown areas, which are very hard to find, there's some very poor there as well, but there's not very much of it. And on this slide, you can now see that the Hoo Peninsula is there for you to see, and if you can remember the previous map where all that large area of excellent agricultural land was, you'll see that land in yellow or a sort of cream colour, dark cream colour, as well as being very good agricultural land, it's also an area of underlying clay. And so it's great for growing because it's grade 1 agricultural land, but it's tricky to build on. So you may be asking, why are they wanting to build on this area? So just to give a little bit more detail of the agricultural land in the Hoo Peninsula, there is no poor land. About 40% of the land is excellent, 10% is very good, 25% good to moderate, 15% poor, and 10 urban. Half of the Hoo Peninsula's land is excellent or very good. Some of the land graded as good to moderate, and all of the land graded as poor is marshland, recognised as of international significance for bird life and biodiversity. So it's precious in its own right. And here we have some grade 1 agricultural land on the Hoo Peninsula. So agricultural land, apart from allowing the natural world to thrive and to grow food, the plants grown on the land take carbon dioxide out of the atmosphere, improve the air we breathe, and help to fight climate change. Every square metre of agricultural land is working for us and helping to make our environment better. Grade 1 agricultural land, trouble is there's not very much of it, which sort of highlights the point that the large amount that we've got on the Hoo Peninsula is of even greater significance. Do you want to say anything else about that, Bernard?
No, just, isn't it lovely?
Yeah. Okay, isn't it lovely? Yeah. And this is very familiar to me, this piece of land, and this is also grade 1 agricultural land. So grade 1 agricultural land took centuries to build up to the fertile, rich layer of soil that it consists of. It takes a day with a volume house builder's bulldozer to destroy it. Once it has been destroyed, you can't get it back. It is a complex living organism with more microbes per square centimetre than there are stars in the sky. It is inconceivable to me that we would allow this natural asset to be turned into the source of more greenhouse gas emissions, more pollution, and even more disastrous consequences due to climate change. When we can say no to the volume house builders and save our precious agricultural land.
Now, this is a site that a farmer has left fallow for a couple of years because he thinks he's going to get permission to build 760 houses on it at High Housestone, something that's going to double the size of the village in a very short time.
This piece of land is down the road from me. The volume house builders managed somehow to obtain permission from our elected representatives to carry out their acts of vandalism on our environment, our food security, and our future well-being. They can promote themselves by advertising on such things as We Are Medway website. But a big part of the problem is that they can still do it legally. So on the screen at the moment, this is a screenshot of the We Are Medway website, and you will see at the bottom there names that you probably recognise. Redrow, Taylor Wimpey, Esquire. Thermal performance. The building regulation requirements for thermal performance of buildings are totally inadequate. Under a previous government in 2006, we were promised zero carbon buildings by 2016. That's some time ago. This promise was renegaded on by the then coalition government in March 2011. The present government has made internationally binding commitments for the United Kingdom to be carbon neutral by 2050. That's a long time after 2016. The construction industry globally is responsible for more than 40% of all carbon dioxide emissions, while in the UK, it accounts for 49%. So we're kind of worse at this than other countries. All the professional bodies associated with the construction industry say that all new buildings must be carbon neutral by 2030. They also say that by 2050, it will be too late.
This is houses that have just being built at Hoo, and they are inadequate in every sense of the word, and going to have to be retrofitted to make them up to the standard we're going to have, within the next 20 years probably. And that applies to, everywhere and all houses being built now.
Bringing new buildings up to net zero carbon standards is easy compared to retrofitting the millions of existing buildings. All but a handful of existing buildings need expensive and complex adaptations to conform with our commitments to keep climate change below 2 degrees centigrade. We have the technology to do the job, but it's a big task. A task made harder by all the substandard buildings currently being produced by the volume house builders. So why we are continuing to build houses that are going to be needing to be retrofitted at greater expense, I don't know. And I'm actually going to hand over to Bernard now, I think.
Greenhouse gas emissions. These are commonly referred to as the cause of climate change. They form a layer of gas around the Earth's atmosphere that absorb and emit radiant energy. They reflect the Earth's heat back down and make the Earth habitable. But that is within a very fine temperature tolerance that we are adapted to. They mostly consist of carbon dioxide, methane, and nitrous oxide, but are measured in carbon dioxide equivalent, CO2e, as carbon dioxide is the biggest contributor to greenhouse gases. Carbon dioxide emissions. Currently, the construction of the average brick-built house emits 65 tons of carbon dioxide. This is the embodied carbon dioxide content of the house. Each year, the average household emits 2.7 tons of carbon dioxide. This is the operational carbon dioxide content of the house. Over a period of 60 years, the operational CO2 emissions for the house would be 60 times 2.7. That equals 162 tons of CO2. Added to the embodied carbon from the construction of 65 tons, the final carbon total for the house is 227 tons of carbon dioxide. So what does this look like? Can we ignore it? Right, now this is what mature woodland looks like. So we now come to talk about offsetting. This is the idea that you can turn grade 1 agricultural land into a building site and offset the damage done to the environment by planting a few trees. Is absurd, but nonetheless part of Medway Council's strategy. 100 houses on, say, 3 hectares of grade 1 agricultural land would need 59 hectares of mature woodland to sequester the CO2 emissions from constructing and living in the houses. A hectare of mature trees captures about 6.4 tons of CO2 each year, and over 60 years this would amount to 384 tons of CO2 being captured, equivalent to the emissions from just 1.6 houses built to current standards. Unfortunately, land is not being created at present, and we would need 176,500 hectares of woodland to compensate for the 300,000 houses planned by Boris Johnson to be built every year. So this is a picture of Kentish woodland, and I've called it Bluebell Rise because if you go near Lenham now, you're going to see a development there of new houses called Bluebell Rise. And this is probably what it looked like before the volume house builders got there with their bulldozers. If we planted trees on every hectare of UK grassland to compensate for our damaging way of building, we would have run out of grassland before 2050 and run out of milk and meat a lot sooner. But we have the technologies and the strategies to deal with the problem. We are just not using them. Ironically, growing trees on some of our grassland could be a part of the solution. In terms of reducing to zero the operational carbon emissions of the average house, there are 3 things to be considered: the building fabric, the building services, and the building layout. So this is the building fabric, and this is Marilyn's all timber house. It is relatively easy to create a building that is, say, 95% thermally efficient. You just need lots of insulation, triple glazed windows, and careful construction. The last 5% of the thermal efficiency is much harder to achieve. involving air tightness and the elimination of cold bridges. Now, with services, we are becoming familiar with wind and solar power that are rapidly taking over our national electricity generation. Less familiar are ground source, water source, and air source heat pumps that we need to replace the gas, oil, and coal for domestic heating. This is that affordable house that Frank Lloyd Wright built back in 1936, and this is the internal layout, which is one of the first houses ever to be open plan. Modern efficient solar panels repay their carbon footprint in about 3 months, but it is very important that the building is designed properly. Equally important is the size and orientation of the windows, allowing for solar gain to occur only when and where desired. So, with eliminating operational carbon emissions, we can have zero energy bills to go along with our net zero carbon emissions. And when it comes to marketing houses, I think it would be a good selling point to say that you actually don't have any energy bills to pay in this house. That might encourage people to buy them instead of what the volume house builders are offering. Now, coming to timber housing in general, this is an example of timber housing built in 1849. And it's built in Washington State at a place called Fort Vancouver. Right, so we still have an average of 65 tons of embedded in the building fabric to contend with. The first material to be promoted is timber. From all those carbon sequestering forests we have planted on marginal grassland. The first material to demote is brick, and along with it, everyone's preconceived idea of a house. Making 1,000 bricks is about equivalent to 1 ton of CO2, whereas 50% of the weight of timber is in captured carbon. This is another timber house. This is the Hyde residence in Washington State. So why is the embodied CO2 in our buildings higher than the global average? Historically, our home has been our castle in Britain, literally with heavy mass construction and highly processed materials. Other countries, as the US, use lighter construction and have fewer highly processed materials. Our construction industry hasn't adapted to changing circumstances. E.g., there is no dimensional coordination between different materials. So in the future, we need, or immediately, we need to build less. We need to ask ourselves, can we satisfy our requirements some other way? We need to build light. We need to reduce the weight of the structure, avoid long spans, build wise, build long life, low energy or no energy, and loose fit. Build low carbon, use natural and renewable materials. Build for the future, design the building to be adaptable and recyclable. Build collaboratively, involve the client and whole team in design. Eliminate waste, use factory-made components. Coordinate dimensions, have no cutting tools on site. Now, the reasons we're not using these technologies and strategies, the first one is that the giant construction companies don't care. They're only responsible to their shareholders who could live anywhere. Second one is that massive re-education and upskilling is required in the industry. The third is the material manufacturers have a vested interest in the status quo. And the fourth is that the government doesn't have the foresight or courage to do the right thing. They talk the talk, but that is all. So this is a blurred picture of a very light construction dwelling. And this is a house built in 1966 by Walter Siegel. And Walter Siegel was a visiting lecturer at the School of Architecture that I went to, and a very inspiring architect. And he was doing most of these things nearly 50 years ago. The volume house builders didn't listen then. And after my more than 50 years in architecture, I don't think they listen. If they won't listen to the architectural profession and all the other construction professionals, maybe they will listen to their potential customers. So the Medway Green Party would like the future occupiers of houses to have a say in the design and construction of their houses. We propose to produce a green guide to buying a house. This, we hope, will give people the opportunity to demand a house that will not destroy our environment, will meet our climate change commitments, will be a healthy place to live, will have zero energy bills, and be adaptable to meet their changing needs in the future. So guys, watch this space. Thank you for joining us and helping us to make Medway and the world part of a fairer, kinder, and more sustainable planet.